This is the Signal and System Practice Homework 3.2, Question 1. Using direct integration, find the three convolutions. The first one, the convolution of ut with another ut. Based on definition, the integral of the u tau times ut minus tau d tau. We can see for the u tau, we know that is equal to 0 when the tau larger or equal to 0. Otherwise, the tau the u equals to 0. And for the ut minus tau, similar, once the t larger or equal to tau is equals to 1. Otherwise, u equals to 0. Based on these two equations, we can, for the better understanding, we can just plot it. Tau 0 and for we can see for the tau larger than something like this, and for the second one equation, we need to consider the different situation for the t. When the t larger than 0 or smaller than 0, we need 2. Once the t larger than 0, it's going to be something like this. And once the t smaller than 0, it will be looks like this. This is t. And in the integral, they time together. So for the first one, once the t larger than 0, we combine these two plots, we can see something like blue one and the green one. This is t and there is 0. And we can see these two, there is an overlap. So if we name the original equation is 1, so 1 equals to the integral from 0 to t and 1 d tau, then equals t. And similarly, we can get 1t smaller than 0, or even we can just see small equals to 0. There's no difference in the connection point. The plot gonna be look like something like this. The blue one and the red one. So we can see these two equations, there's no overlap between them. So the original one gonna be just equals to 0. So eventually the final results will be like the convolution of ut with another ut will be equals to t, 1t larger than 0. Otherwise equal to 0 when t smaller or equal to 0. That's the final answer for this one. And for next question is a convolution of e to minus at ut with another e to minus at ut. We just based on definition, the integral of the e to a minus a tau u tau times e to minus a t minus tau u t minus tau d tau. We switch these two positions in the front so we can get e to a t u tau u t minus tau d tau. We can see here e a t, they all the constant is not a function of the tau, so we can move in front of the whole integral, so we can get e to minus a t, the integral of u tau u t minus tau d tau. And this part actually is the result of the first question, so we can directly get e to a t times t, 1t larger than 0, otherwise just directly equals to 0, 1t smaller or equal to 0. Then we are done for this question. For the last question is the convolution of the t ut with another ut. Similar steps. According to definition, the integral of the tau u tau times ut minus tau d tau. Since this tau is really not influence the later part, if the u tau times ut minus tau is equals to 1, it's just tau itself. If this the later part is equal to 0, then the whole equals to 0. So we just can based on the previous results, we can just directly get it's like when the t larger, like this results, like these two results, when the t larger than 0 is equals to t, and okay. So let's see. When the t larger than 0, we name this equation is 2, so we can 2 get 0 to t tau times 1 d tau, and we can get equation and 0 to t, so we can get 1 over 2 t squared. And when the t smaller or equal to 0, the equation 2 gonna be just directly equals to 0. So combine the 1 and 2, we can get final results. The convolution of tut with another ut equals to 1 over 2 t squared, 1t larger than 0, otherwise is equals to 0. So that's the results of this problem. Thanks.